Hi everyone, I'll introduce our work on a new representation for the vector fonts. 2D shape generation of stylized fonts has important applications in art and design. There are multiple forms of input available for neural networks training. Among those representations, vector-based methods suffer from ambiguity brought by the many-to-one mapping from the drawing commands to the rendered shape, and pixel-based methods often produce blurry boundaries. The neural implicit representations excel in producing higher quality overall shape, while suffer from the inherent smoothness of the MLPs, and hinders these methods from accurately modeling high-frequency geometric details like the corners. Therefore, in addition to SDF, we adopt a new implicit field, decompose the high-frequency signals into the fields, and jointly render these two implicit parts into vector fonts. Our joint representation includes two implicit components, a sign distance field, SDF, and a corner field, CF. We train two networks to represent these neural fields respectively, and then jointly render the outputs of these networks into vector shapes. With the power of hypernetworks, we could obtain the latent space of the data efficiently and effectively. The sign distance field is employed in our representation to depict the overall shape. In addition to the reconstruction loss, we utilize surface normal and iconal loss to impose constraints on the SDF. Different from SDF, our newly proposed corner field is a probabilistic field. It indicates several local regions where corners exist, and the number of corners is equal to the number of maxima of the field. The values of points in the corner field are determined by their distances to the nearest corner. We also utilize the reconstruction loss to constrain the CF value, although it alone is insufficient for achieving accurate CF representation. To enhance the field strength around the corners and prevent multiple maxima in local regions, we introduce a peak loss. To ensure alignment between the corner field and sign distance field, we supervise the corresponding SDF value in the output of the CF network, but this supervision is not utilized during final inference and is referred to as SD flow. SD flow plays a crucial role in achieving smooth interpolation. These training data can be analytically computed from the ground truth vector data. Finally, we propose a novel vectorization process to convert the SDF and CF into vector fonts. In this part, we first extract the contour points from a zero-level set of SDF. These contour points will be connected in a certain order to ensure the closure of the final generated shape. Then we locate the corners by dual contouring. For each peak of the corner field, we find the nearest contour point generated in previous step. This contour point will split the contour into two parts. We determine two lines on both sides of this point. These two straight lines are determined by the coordinates and normal vector of the contour point, which are approximate to the tangent of the contour surface, and their intersection is the final obtained corner. We combine the contour points and corner points we get, starting from one of the corner points, and incrementally generate a vector shape. They will eventually be converted into a bunch of straight lines and quadratic Bezier curves. The joint implicit representation achieves high performance in reconstruction and interpolation tasks. Our representation provides high-fidelity font reconstruction results and maintains a latent space that enables for smooth interpolation both for shapes and corners. Compared to our approach, other methods either do not well sharpen the corner, or the interpolated intermediate results do not have good corner correspondence. Furthermore, the vectorization method produces visually compact vector shapes, without redundant lines stretching across the shape. Also, the number of commands and control points of the rendering results are competitive compared with the vector-based methods, and significantly outperform the previous implicit representation. Since we adopt an incremental curve fitting scheme, there could be a flexible trade-off between fitting error and the number of curve primitives. In the ablation study, we conduct experiments on the loss function proposed in the corner field and train several models of SDF net with or without hypernetworks to verify its importance. The peak constraint helps avoid multiple peaks around the CF with a single corner. The SD flow has the capability of soothing the ambiguity brought by the multiple correspondences during CF's interpolation. We propose a metric measuring the divergence between the interpolated and original corners. Without SD flow, the corner might disappear in the intermediate results. The ablation on hypernetworks proves it significantly enhances the accuracy of font representation. However, augmenting the network parameters does not consistently contribute to reconstruction, thus, there's ample room for improvement in the architecture design of hypernetworks. At last, we hope our work can inspire new directions for integrating high-frequency details in areas like 3D shape modeling and generation. Thanks for listening.